See if you can figure this one out. There is a 20% chance of heavy snow tomorrow. On average, school is cancelled 4 days out of 180 days each year. What is the probability of the kids staying home for a snow day? Tomorrow, I meant to say. Tomorrow. Okay, so it's 20% chance of heavy snow tomorrow. On average, school is cancelled 4 days out of 180 each year. What's the probability of the kids staying home for a snow day tomorrow? Please press pause on the video and try that one yourself. Okay, I hope you've pressed pause and you've tried it. So I'm going to do it now. And the answer is that the answer is probably in this area about 20%. That's the answer, right? Why is that? Because if there's heavy snow, they'll probably stay home from school, right? And this part doesn't matter at all, because these events, this event, school is cancelled, and heavy snow, these are dependent. Okay, school being cancelled oftentimes does depend on whether or not there's heavy snow. Okay, so the wrong way of doing this would be to go, and we'll just do it for fun. The wrong way would be to use the product property without first checking for whether events are independent or not. So like 4 out of 180 is 0.222. So we could just do, so probability of event A is 20%, and probability of event B, school is cancelled, is 4 out of 180. So 20% is 0.2, and multiply that by 4 out of 180 to get the probability that it will there'll be heavy snow and they'll stay home from school. So, or let's see here, 0.2 times 4 out of 180. Okay, 0.0044, etc., or approximately 0.44%, something like that, right? So 0.44% would be the incorrect answer, right? Whereas about 20% is probably more likely, although we don't know for sure, okay? Because these events are dependent, right? So the heavy snow increases the likelihood of school being cancelled, right? So this probability goes up, right? So these are dependent events, and that's why we can't use the product property. We shouldn't have used it because the events are dependent, not independent, right? And so that's an obvious example. This one is a little bit murky, but let's see what you think of this. A basketball player has scored 54 out of 79 free throws so far this season. What is her free throw percentage? Calculate that free throw percentage. Well, I just get 54 out of 79, right? So that's 0.6835 and so on. I'm just going to say that's about 68%. Okay? Approximately, right? Are consecutive free throws independent events? Can we use the product formula? What do you think? So part B, are they independent events? In other words, if you're taking free throws one after the other, is the probability of each free throw 68%? 68% for a free throw, and then throwing a basketball into a hoop, and then take another shot of the basketball, is that also 68%? And then the next shot is also 68%, and the next shot is also 68%? Does scoring affect the likelihood of scoring the next time? Or is each shot exactly about, or as a basketball player, is a person more likely to are they gonna be better as they score more or score less or what? And it's a difficult one to answer because maybe they could be on a roll, right? And they're in form and they're more likely to score in each shot. So maybe their likelihood is more like 80%, 80%, or maybe if they're scoring, that they might start to get nervous that they're going to miss the next one. I don't know. It just depends on the person, and then their likelihood might drop down to 40%. Who knows, right? So it's hard to know if it's independent. But so this one's hard to work out. But let's just say that just for fun, we'll just say that they are, right? And so imagine they are. So imagine you have a basketball player that for that particular player, they're pretty consistent. And so whether they've scored the previous shot or not, they're just as likely to get the next one because they're just sticking to their form and doing their best each time. So what is the probability that this player scores 2 free throws in a row? What do you think? So probability of scoring times probability of scoring, right? So we'll just imagine they're independent, like I said, and in that case it would be 68% or 0.68 times 0.68, right? And that would give us the answer to C, right? Or even better, it was, 54 out of 79, right? Which is that number. I'm just going to hit the squared button on my calculator. See that? Answer squared. And that'll give me more accurate. Or I could do, once I have that, I could do to the power of the little hat button 2, right? And that would give me, again, 0.467, or about 0.47, or about, what's that as to the nearest percentage? To the nearest percentage? It's about 47%, isn't it? Right. So, part D now. Press pause on the video and do part D yourself. What is the probability she scores 10 free throws in a row? Did you press pause and try it? So again, we're going to assume this is a pretty consistent basketball player, and her previous shots are not affecting her chances of getting the next one, whether she scores or not. And so just imagine that each free throw, she has the same chance of getting it, right? So we can use the product property, so about a 68% chance each time, right? So multiply 0.68 by itself 10 times. That's the same as going 0.68 to the power of what? To the power of 10. Or to be more accurate, we should do, in fact, the 54 over 79 and then to the power of 10 in the calculator. That would be more accurate, wouldn't it? 54 over 79 to the power of 10, right? So I'll do parenthesis 54 over 79 to the power of 10. And that gives me 0.02222. Give me that as a percentage rounded to the nearest percent. So move the decimal point over 2 spots to the right. It's about 2.2. Round to the nearest percent. That's about 2%, right? So if this is the basketball's player's free throw percentage, then to get 10 free throws in a row, let's say, 10 shots in a game or something, chances of getting them all in would be 2%. And I'll just give you one more. What if we had a basketball player with a free throw percentage that was top of the NBA, something like 88%. Okay, what would the chances of getting 10 free throws be now? So calculate that. Probability of 10 free throws scored in a row. Okay, did you try it? So I'll help you right now. So if it was 88%, it'd be just 0.88 to the power of 10, right? Or in a calculator, 0.88 to the power of 10. Because it's 0.88 times itself 10 times, right? Round that to the nearest percentage. So move the decimal point over 2 spots. And we get about 27.8. So just round that up, it's about 28%, right? Which is interesting. So a seemingly small improvement on the individual shot from 68% to 88% results in a much more likelihood of getting all 10 shots in a row, right?